Hello, How to Fold Soup and 999 Bob 666. You challenged me to brute force um, Soup's demonstration of the problem, and I'm here to do exactly that. Um, Soup became real close to demonstrating for everyone in a very convincing way of your transformation of the problem, and I couldn't resist taking the opportunity to go ahead and just complete the thing. So the thing is, you transform the problem by basically doing 52 doors, but in each case you were sort of like looking at the cards so that you could pick one, and it wasn't really random. So I'm just going to go ahead and transform the problem twice. Uh, One, of course, is the 52 doors, as you suggest. And what I'm going to do is I'm going to shuffle, unlike you, I'm going to shuffle the cards and then not look at them. Choose one card at random, with the idea of that being pretty much equivalent to asking you, the viewer, to choose a card. I mean, we're all just looking at the backs of cards. What the hell? I mean, there's no difference, right? And of course, I'm going to demonstrate to you right now that these are just ordinary playing cards, and then I will very quickly shuffle or just pan all of them so that you know I'm not playing any games here. There's the Ace of Spades that we're looking for, and if you want to care to do so, you can slow that down and demonstrate to yourself that in fact that there are 52 cards. Also, the perspective I have with the camera here, I want to make very clear that although I'll be like shuffling and showing the cards at roughly this position, that I'm actually quite far from the edge of the table here, right? I'm moving my hand vertically, and so we can see that, and I have short sleeves here, so I am not playing magic tricks. This is all for real. There's nothing else going on here. So without further ado, we're going to go ahead and oops. Let's see if we can shuffle a little bit more properly. Okay. So I like doing this kind of shuffling, and so to demonstrate, I do a full half over so that there's no cards at the end. Really, I don't have any. And then finally, just to really, obviously there's no way I'm seeing the bottom of those cards. There's no mirrors or anything like that. Cards are low on the table. Okay, so these are a well shuffled deck, and we just fan it out. Of course, I cannot see the cards. You cannot see the cards. So when you choose the cards, I can make the choice for you. There's no difference. It's just a back of cards. We're here. Okay, so this is going to be the door that we've chosen. And now I'm going to play the part of Monty Hall, and I now have information. I'm now looking straight at the deck, straight at the cards. And so I'm going to either pick out some card at random, or the Ace of Spades if it's available to me, place it here as the alternate, and then, unlike what How to Fold Soup did, I'm going to show you actually what the remainder of the cards. Okay, and so we can see definitely there is no Ace of Spades. So that's Ace of Clubs, not Spades. And in the remaining of the deck at all. Remember, this was the card that we just picked face down at random. This is the card that So anyways, the Ace of Spades is not here, as I showed you. This is the card you picked at random. So the Ace of Spades is either here or here. So the question is, do you want to pick or stay? Right? And I think it's pretty obvious. This is the Ace of Spades. That's something else. Okay. As I said, I got to do that now. I did it slowly the first time, but I'm just going to do it very quickly from now on. I'm going to do it 4 times in a row. Right? The point of that is that if I do it 4 times in a row, I have basically a 7.5% chance of failing to demonstrate this. Okay, I guess that's shuffled. Once again, we're just fan out and whatever. I'm gonna pick one pick a card at random. So trying to center it on the screen. I played the part of Monty Hall. I'm looking through the deck. And if I find the ace of spades, basically what I'm going to do is isolate that card so that, and then of course I have to show you the rest of the deck. This is an important step. It's a little bit time consuming, but it's important. So really fire those intuitive juices there. Okay, there's no ace of spades in there. Again, this is what you chose. This is what we chose at random. And this is the other card. There's no ace of spades here. So the question is, where's the ace of spades? Well, once again, switching was better. Okay. Ace of spades, so. Overhand. Okay. Once again, fanning out. This is attempt number 3. Part of my Monty Hall. Looking for our special card. Once again, demonstrating that the deck does not contain the ace of the remainder of the deck does not contain. That's ace of clubs, ace of spades. Once again, switching was a better choice. That was attempt number 3. Now on to the 4th and final attempt at the exact same thing. Okay. Once again, we're just gonna, let's pick something up near the top this time. Playing part of Monty Hall, we're flipping the deck up so I can scan to see which doors I'm supposed to open. So that's the one I leave closed. Scan, I'm going to show you the rest of the deck. Essentially, this is opening the doors, right? This is opening 50 doors, basically. Right? Showing that there's no ace of spades, which is what we were looking for. Okay. This 4th and final attempt. Do you stay or do you switch? So this was the original choice. This was the one left after opening the doors. Once again, switching is the better choice. So, there you go. 4 times in a row. Brute force demonstration, if you consider the statistical significance of that. So where am I getting this whole 7% business? Basically, the chances that switching, look, the chances that you pick the ace of spades right off initially was in fact 1 in 52, or 2%, as How to Fold Soup suggested. What that means is once you open 50 other doors, the ace of spades has got to be in that remaining spot. So that's 90, that's basically 98% is the remaining, right? It's 51 and 52 is the point. So by doing it 4 times in a row, what I've done is essentially you take the number 52 over 51, plug it in your calculator, raise that to the power of 4, and you get roughly 0.925 as the final outcome. what that means is there's a 92.5% chance that my demonstration here was going to work, and that switching would always lead to the ace of spades. And of course, that's exactly what happened. So this is like a real true statistical demonstration of the Monty Hall problem with these two transformations, which I think are okay. Anyways, that's all I had. To be later.